All right, so today we're learning about graphing relations, and the relations are based on the tables that we learned the previous lessons. So take a look at page 17 in your booklets. I'm at the top. So we're basically looking at the relationship of the input to the output. Now, last time we talked about how the input, we can show how the input goes up 1 each time, and the output goes up 5 each time in this case, okay? And that's important because you want to look at, when you're graphing something, you really want to look at scale. Now, you've done line graphs before. Those are the graphs that have dots, and then you connect them with a line, with a ruler, not like how I'm doing just freehand. Okay, that's called a line graph. Now, you've all done line graphs, and the line graphs you're going to be making for this lesson are based on these tables of values, okay? And so you will be completing the table of values and then using that information to make little tiny line graphs. So the reason that the input and the output is important because you want to think about scale. Input often just goes up by 1. That's the bottom here, okay? See, the input goes on the bottom. And it often just goes up by 1, so your scale is just what? 1, 2, 3, 4, 5, or it might start at 10, 11, 12, 13, 14. It doesn't always go up by 1, but normally it does. So check that out. If it goes up by 1, you don't need to count by 2s or 3s. Just count by 1s because you want to graph each one that's in the chart. Okay? Now your output is a completely different situation. The output often doesn't go up by 1. Often it's going up by 5 or 6 or 10 or 12. And here's where you have to make the decision on scale. Okay? What are you going to count by so that the graph doesn't go off your page? Because if you counted by 1 in this graph, see, we're going up to 21 for the output. So you can't count by 1 and have the graph make sense. It's going to be like super tall. You want to count by, and they decided to count by 4s each time. 4, 8, 12, 16. That's not the only option. There isn't really a wrong one. Well, there are several options. There are wrong ones. You probably can't count by 1. You can't count by decimal 5, right? But you could also count, in this case, by 5s, okay, by 4s. You could probably get away with even counting by 3s since it's only going up to 21, okay? So you want to make sure your scale matches the values that you're getting. If you have values up to 100, what might you count by? If you have output values to 100, what could you count by? You could count by 10s. Yeah, that would make sense. That's 10 steps. Yep. You could also probably count by 20s. 25s, that's only 4 steps. That might be a little low. You want to kind of make, if you have 5 inputs, you want to try and have around 5 numbers on the side for your outputs as well, give or take, okay? So that's where you're going to be making decisions on your output side. So remember, input goes at the bottom, output on the side over here, okay? The input is usually just counting by 1s. The output, you have to make the decision on what you're going to count by, and you make little tiny graphs. You put your dots, and then you join them up. Okay, the line doesn't have to touch all the dots. Okay, it's kind of like an average. Okay, so if this dot, like for linear graphs, so this description right here at the bottom describes the graph. It's on your page, on page 17, right underneath the graph. So even though it goes off my page a little bit, you can still see it in front of you. So the output axis, that's the one on the side over here, the one that's going up and down, the y-axis, okay? That one says it's 1 square to 4 units, okay? That's the scale, 1 to 4. So every time the input goes up by 1, the output's going up by 4. Does that make sense? Yeah? Okay. Okay, so it just shows that that's the relationship that we have here, okay? The points lie in a straight line, so the relation is linear. Okay, this is a great way to describe a graph. It's linear. It means it's a straight line. Most of your graphs are going to be straight lines because they're patterns. Okay? Both the table and the graph show that when the input increases by 1, the output increases by 5. Okay. All right, so what you're going to do, you're going to be completing your graphs on your tables on the bottom, and then making graphs on the second page. Okay, it's going to ask you to. It might ask you to describe the graph and go back to this. Okay, go back to this as an example on how to describing a graph. So please circle this underneath the table, and put describing a graph. This is a great example, and when they say describe your graph, what does it look like? How is it going up by? Okay, what is your scale? Actually, that's 1 to 5, sorry. Not 1 to 4. Okay? Because it's going up by 5. Okay, what is your scale? Okay, and is it a straight line? Is it linear? Okay, so this is a great way to describe graphs. So they ask you to describe your graph. Don't say I used a ruler, it's done in pencil. This is what you're looking at. Okay? All right, so we're going to work on page 17, 18, and 19. And then if you're not done, page 16, then feel free to go back and finish the tables first. You're going to have time this class and a little bit next class. Okay? Thanks.